Good morning, friends, and welcome to another episode. In today's episode, we'll be looking at how to calculate the oxidation number of some elements or of some atoms in compounds or in molecules. In the previous video, we looked at oxidation numbers and we looked at some atoms and their oxidation numbers. For example, we looked at hydrogen and we said that hydrogen has oxidation number most of the time of 1, and oxygen usually has oxidation number of -2. Elements in the group 1 usually have oxidation number of +1. And we also come across some elements or some atoms that have variable oxidation numbers. And in fact, most of the atoms we are going to be dealing with in this particular section are atoms with variable oxidation states or oxidation numbers. And we'll be calculating the oxidation numbers of these atoms. So there is a particular rule that we learned about in the previous lesson. We need to recap on that rule. And to do that, I would write the chemical formula of a compound. So H2, let's say SO4. Sorry. Now, every compound has charge on that compound, or every molecule has charge on it. And usually the charges of these compounds or molecules are written as superscript on this part of the compound. So what it means is that if you do not see any number written at that portion of the compound or element of the molecule, it means that that molecule do not have a charge. In this case, H2SO4 will not have a charge because there's no number written there. So the charge on this entire compound is 0. Now H2SO4 is also made up of individual atoms. In this case, we have 2 hydrogen atoms, and we have sulfur here, then we have 4 oxygen atoms. Now, in any molecule or in any compound, anytime you add, you see you have the atoms in this molecule. Anytime you add the individual charges of all the atoms in the molecules, or in the molecule, sorry, you add all of the charges together, it should always be equal to the charge on the compound. So here, if I have you have 2 hydrogen atoms, so if you know the charge of hydrogen, add that together to the charge of sulfur, add that together to the charge of the oxygen, it's 4 of them, you add them together, it should be equal to 0 in this case. That is the rule we are talking about, and the rule is simplified in this way. The algebraic sum of the ionizations or of the charges of all the atoms in a molecule will always be equal to charge on that molecule. So this is the charge on the molecule, and this is the algebraic sum of all the individual atoms, the ionization numbers or of their charges being added together. When you add those charges together, it should be equated or equal to the charge on the entire compound. That's what the rule states. And we are going to use that in our calculation. And in this, most of the calculations we are going to do, you'll be given a compound or a molecule and you'll be asked to calculate the oxidation number of a particular element in that molecule. Let's start with our first example. So here we have H2SO4, and our work is to determine the oxidation number of the sulfur in the H2SO4. First, from this compound or from this molecule, it's very clear that the charge on the entire molecule is 0. The molecule has two hydrogen atoms plus sulfur atom plus four oxygen atoms. So, but we know the charge on hydrogen, it's usually positive one. The charge of sulfur is what we are looking for, plus 4. The charge of oxygen in most compounds is usually -2. Let's write it here equals to 0. This now becomes mathematics. We would use this to determine the charge of the sulfur. So this will give us 2 plus the sulfur minus 8. 4 times -2 is -8 equals to 0. So our sulfur 2 minus 8 will give us -6 equals to 0. So the sulfur will now have charge of positive 6. So this positive 6 is the oxidation number or the oxidation state of our sulfur in this compound or molecule. Normally, we would use this in naming this compound. And normally, when you are doing that, you write the 6 as a Roman numeral. So 6 in Roman numeral become V. As simple as that. This is what you'll be using in naming this compound. But the oxidation state or number of the sulfur and this compound is positive 6. Let's look at another example. In this example, we have HCO3 minus. So here clearly the charge on this compound is -1. The compound or molecule has hydrogen, it has carbon, and it has 3 oxygen atoms. Charge of hydrogen is usually 1 in most compounds, plus the carbon which we are looking for. We are looking for the oxidation state of the carbon. Then plus 3, the charge of oxygen which is usually -2 equals to -1. So we have 1 here plus C, then this will give us minus equals to -1. The C is repeated. 1 minus 6 will give us -5, right? That will be equals to -1. So our C will be equals to, which is the carbon, will be equals to -1 plus 5. That will give us positive 4. So this is the oxidation state of the carbon in this molecule. It will be 4. 4 in Roman numeral will be IV. This is what you would use to name the compound. When you are naming the compound, you use the 4 IV to name it. Let's move on to the next item. For the next item, we have PO4 minus 3. The charge on this molecule is clearly -3. The molecule is made up of P, which is phosphorus, plus 4 atoms of oxygen. We are looking for the oxidation state of the phosphorus. So let's continue. So that's phosphorus plus 4. Charge of oxygen is usually -2 equals to -3. So B, this will give us -8 equals to -3. So B will give us -3 plus 8. -3 plus 8 will give us positive 5. So that's the oxidation state of the phosphorus in this molecule. 5 in Roman numeral will be V. So V is what we'll be using to name this compound. Let's look at the last example. So here we'll be looking at HNO3. So here the charge on this compound or molecule is clearly 0. It is made up of hydrogen plus 1 nitrogen plus 3 oxygens. Charge of hydrogen is usually 1 plus the nitrogen. Remember, we are looking for the oxidation number of nitrogen plus 3 of the oxygen, which is equals to, sorry, let me clean this. So the charge on oxygen is usually -2 equals to 0. So 1 plus the nitrogen, this will give us -6 equals to 0. Our nitrogen, 1 minus 6 will give us -5 equals to 0. So our nitrogen will be equals to positive 5. So the oxidation number state of the nitrogen is positive 5. In Roman numeral format, it will be V. That is what you'll be using to name this compound. So as simple as that, that's how you calculate oxidation numbers of elements or atoms in molecules or in compounds. Please, that will bring us to the end of today's lesson. Share the video if you've not already done that. Then subscribe if you've not already subscribed to the video. Remember, we are here for you. And please remember to take very good care of yourselves. Bye.